Now in this video, I'm just going to bombard you with lots of examples. So given what we've derived so far, solve this here. Basically, 5 to the power of find x here. What 5 to the power of this thing here equals 40? What must x be? Okay. To solve this here, visualize as this 5 to the power of a bubble. Okay, so now log equally to both sides. So really we are going to now use this, and which one? This one here. So when given something like this here, if you log base a of this thing here, then you can just simply take the n out. Okay, whenever you have this here, log equally to both sides. That will then give you this. And remember, this by you using this property here, a could be to any base here. It will still work. So when you have this here, log to both sides, it could be log 10 or it could be log 2. It doesn't matter on the base. It will always work. So here log equally to both sides. That will then give you this. But when you are here, skip this step here. Just jump from here to here. So when you visualize it like this, log equally to both sides, move this down here. So jump from here to here. Okay, and then that will then give you this. Divide both sides by this log 5 here. That will then give you this. And bear in mind earlier that the bubble was 3x plus 1 because because of this. Look, the bubble here is 3x plus 1. So blah 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 here, x equals this. Okay, so what that means is that if you put this number into this x here, it will give you 40. Okay, so next example here, given what we've derived, given what we've derived before, to solve this here, to solve this here, hang on. To solve this here, visualize it as one block equals this block here plus this block here. So if you take away this block from both sides, that will then give you this. Take away this equals this here. And remember from this property here, whenever you have one block taking away this block, you can merge the x and y together. Okay, so here we've got, hang on, here we've got one block taking away this block here, so we can merge them together. So 7 divided by x, because you're actually using this property here. Okay, so that will then take us to this, and then hang on, that will then take us to this, and then now from here translate it. So your eyes to zoom into the 2. In your mind you should be saying to yourself, 2 to the power of what gives me this thing here. So 2 to the power of what? Well, the what in this case here is 3. So when you translate this, it will become, well, it will become, this is the same as this. So from here, translate it back. So your eyes are zooming to the 2 here. 2 to the power of what gives you this thing here, gives you this thing. But in this case, what is 3. Okay, 2 to the power of what gives, well, in this case, the what equals 3. So now you've got it into here. Keep an eye on x. So times x to both sides, and then here you've got this thing times this thing, divide blah 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 here, and then x equals this thing here. Okay, next example here. So here, let me think. Oh yeah. So to solve this here, visualize it as this thing here. You've got one block taking away another block. So you can, because you've got one log taking away another log. Well, when you do that, make sure the two bases are the same. Okay. Yes, because you've got one block taking away another block, you can merge the two together. So it boils down to this thing divided by this thing. And then and then now translate it back to to the form that we're used to. So your eyes should zoom into this. So it's 11 to the power of what? Hang on. Let me try. So looking at this here, translate it. It would be 11. Because your eyes should zoom into this. 11 to the power of what gives us this thing here? Gives us this thing here, which is this thing plus 3 over 2x minus 3. So it's your eyes zoom into here. 11 to the power of what? But the what in this case is 1. So it's 11. So when you translate this, see, this is exactly the same as this here. So when you translate this here, it will give you this. Okay. So now times both sides by this thing here, and then blah 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 here, and then x equals 2 in this case here. Okay. Hang on. Okay, this last one here. So this last one here, you've got one block plusing another block here. So when you have a plus, you can get this times this. Okay, so 13 times x, that will then give you this. So basically, you've got a log block plus another log block. So that, well, basically you can multiply the two together. That will then give you this. Okay, and then now you notice that this here, you notice that log a of something, and then this is also log a of something. You see, if I were to give you this here, if I were to give you this, hang on, if I were to give you this here, looking at this here, but if I were to give you this here, you could say I'm going to log base a to both sides. So you could jump to this log base a of 13x, and then log base a to the right hand side as well, log base a of 273. So this is what we've got at the moment. What we've got here is this. So whenever you have this, you can actually jump back to this. So my point is that given this here, you can actually jump back to this, because if you were given this here equals 273, you can log base a equally to both sides, which will then give you this. So it's you working backwards. Well, here, this thing here, when you have this exact same thing, you can actually jump to this. Okay. So anyway, this thing here is the same as this thing here. Yeah, because hang on, let me explain it one more time. So when you are here, you when you are here, you could argue that when given this here, hang on, when given this here, you can log base a equally to both sides. That will then give you this log base a of 13x equals log base a of 273. Now, at the moment, this thing here is exactly the same as this thing here. So we can actually jump back to here and make this statement. Okay, so from here, you can actually deduce, well, whenever you have this is also true. Okay, so once you're here, x equals 21. Okay.